Hi, and welcome everybody. I'm Paul Johnston. I'm the Senior Serverless Developer Advocate for EMEA, and this is tips and tricks for developing serverless apps in minutes. Today's session objectives are pretty simple. We're going to understand and look at what the AWS Serverless Application Repository is. We're then going to learn some best practices for creating serverless applications to put into the repository. And then we're going to have a look at some hands-on examples for building and deploying serverless applications. And then we're going to show you how you can build more complex examples by linking services, linking applications together, and looking at composable applications. So this is the homepage of the Serverless Application Repository. In there you can see a search bar. You can search for different applications, and you can very simply just click on them and look at what they do and then deploy them to your AWS account. So quick overview, it's a simple way of quickly deploying code samples, components and complete applications for common use cases, things like the back end to a website, logging, media, very simple things like that, all very complex. The apps are in there and they're packaged using the AWS Serverless Application Model, SAM, which we will talk about. These apps in the repository that you see there are publicly shared apps, and they also include, those ones include the link to the source code as well. And in terms of charges, there's no additional charge to use the Serverless Application Repository. You only pay when you deploy the applications into your account and use the resources within. So we know that when we have a look at deploying serverless applications and any third-party applications, it can be a pretty difficult task to get right. We might go to a third party, we might ask in a forum, we might find a solution on the internet, and we'll have a look at it and we'll review it. Maybe we'll have a look on GitHub or something similar. We'll find a repository, and then there'll be some installation instructions. It's a difficult thing to understand. It's a difficult thing to always get right. We don't always know whether they've had the same kind of background to what we have, or whether they've got the same kind of setups or understandings or security backgrounds. And then we attempt to install these applications. And it's not straightforward. You have to follow the installation instructions. You maybe have to edit more files. You have to integrate it with whatever solution you've got to worry about. These are the kinds of problems that we come up with when we're trying to deploy a third-party application into our own solutions or into our own environments. And it's not straightforward, but it's something we've been used to for a long time. So what we find is that finding the right serverless apps is actually hard. So the GitHub search, it doesn't always give you the right application. Knowing whether the application is right for the use case is not always easy to find out. It may be a good application, or it may not be the right use case completely. It may be a little bit right or wrong, and you don't know if it's good quality. You don't know if it's come from a good security background, or if the developers are actually any good. And the apps are not always connected to your infrastructure. They may have been built for a slightly different scenario, maybe a server-based solution rather than a serverless-based solution. So a serverless application repository tries to fix a lot of these problems. So you search and find applications based upon your use case, instead of not being able to find things that are specific. The repository also displays the publisher, a link to the source code, and an explanation of how each of the applications works. And each of these apps can be deployed into your AWS account by clicking the deploy button and entering the required parameters for the application, which makes it a lot easier, and it goes straight in, and it's infrastructure based. And there's no need to know the language for any of the AWS Lambda functions that are deployed, as each application is self-contained and runs in its own environment. And you can also have public and private applications. So the applications that you see in the public repository are available across all regions. Private applications are actually shared within an AWS account, and can be shared with other AWS accounts, which means that you can share across an organization instead of having to share them publicly. So this is the public AWS Serverless Application Repository homepage, and this is where you would find all the public versions of the applications. And if you want to find the private versions, you would go to the Lambda Create Functions page and click on the Serverless Application Repository section. And in there, you would find the region-based private applications that your account has access to. So using the Serverless Application Repository is pretty similar, but has some extra elements. So you would search for elements in the repository, and the Serverless Application Repository would return you things that you were looking for. So if you were looking for a website generator, you might find Lambda site generator, or if you were looking for an uploader, a serverless web application that uploaded to S3, you might find the uploader application. You would then view the README and the license, decide whether or not that was what you wanted to install, and then you would go and click the orange deploy button for each application, and it would deploy to your AWS account as an AWS CloudFormation stack. Let's just show you that process. So this is the Lambda site generator page. It's a very simple page. It shows you the README. You can click on the license. It's got a little bit of information, and it's got an MIT license. It's also got a big orange deploy button. If you click on the deploy button, you will get to the page where it says Review, Configure, and Deploy. It will show you a little more detail. It will give you the source code, the URL. It will also give you a bit more of a description. It will also give you the permissions that the author has required for the use of the application. It will show you the SAM template, and it will show you the license. We'll go into those in a little more detail later on. And then it will give you a bit more information about the README, and then it will configure the application parameters. So you can change the application name to something else, and it will also ask you for an input bucket name and an output bucket name. Now this, within the context of this application, is two Amazon S3 buckets. So you just choose two Amazon S3 buckets, and you put those two names in there. And then you hit the deploy button. When you hit the deploy button, you will end up with a page that looks like this, and it tells you that your application is being deployed. And if you look carefully, it will say View CloudFormation Stack. What actually is happening in the background is it's created a new CloudFormation stack, and it's deploying into your AWS account. And then when that's done, it will say Creation Complete, and you can actually view that in your CloudFormation page. So AWS SAM extends the AWS CloudFormation specification to simplify definitions of resources for serverless applications. And we also have SAM Translator, which transforms those SAM templates into AWS CloudFormation templates. One thing that's really important is that both SAM and SAM Translator are open source specifications now, and you can have a look at those and exactly what they do, and they come under an Apache 2 license. So if you want to get involved and make updates and improve those tools, you can get involved and help with that effort. So let's have a bit of a look at an example SAM template. This is a SAM template for a very simple application. This bit at the top is a little bit to tell CloudFormation that this is a SAM template. So instead of just a pure CloudFormation, this is a SAM transformation. This little bit down here, which says example function and has a type of AWS serverless function, it's telling us that it's defining an AWS Lambda function. And it's also telling us that the code is to be found in this S3 bucket called SAM demo bucket, and with the zip file of Lambda code zip. And inside of that, it's also telling us that the index handler function is what we're looking for to run when the event actually happens. It is telling us that there is an event that will run the example function. Now that is quite clever because it's also got a path and a method. So this is essentially a catch-all for an Amazon API gateway interface defined to connect to the Lambda function. So what this is actually doing is defining an API with a single function behind it. So just those few lines is a simple API backend. And if we wanted to have a simple table, which is actually a DynamoDB table, an Amazon DynamoDB table, this is how we would do it. And this would be maybe defined for use by the Lambda function itself. So that in itself is a full function with a backend database, functionality for running backend of a website, and an HTTP interface using API Gateway. So one thing that's worth saying, a quick tip, when you're using SAM for creating serverless application repository applications, only certain policy templates are allowed. So when you're using SAM for your own applications outside of Serverless Application Repository, you can actually create policies that are slightly different and more complex. But within the context of Serverless Application Repository, you need to be a little bit more careful about which permissions and policies you can use. For a full list of the supported policies and permissions, have a look at the documentation. It's pretty clear what you can do. So the serverless application definitions for an application are an AWS SAM template, Amazon S3 stored code in a code URL block, and that is a serverless application. So let's have a look at best practices for actually creating these serverless applications. Keep your applications well defined. This might sound obvious, but what a lot of people do is try to do a lot of things in one application. And what we try to say is don't do too much in each application. When you're trying to define what you're doing as little as possible and trying to explain as little as possible is better than trying to do everything all at once. So a few resources per application should suffice. And then consider combining multiple applications together so you can save time by leveraging those pre-built templates and then build more complex solutions. We'll come to this a little bit later in terms of composable applications. But suffice to say for now, better to look at your applications in small pieces rather than large chunks. So here's a small application to look at. This is the Sepia application. And this application, it takes an image file and it puts a sepia filter on top of it. So it's a very simple application if you think about it, but this makes it into an application that you can deploy into your own AWS account. And what it does as an application is define an Amazon S3 source bucket, and it defines a Lambda function. So if you put any image into the Amazon S3 source bucket, it will then trigger an event, which then invokes a Lambda function and then outputs to the Amazon S3 output bucket, which is defined by a parameter. It's very simple, very straightforward, and is a self-contained small application that can be deployed very easily. Okay, so now let's have a look at parameters. Parameters are a part of AWS CloudFormation, but they're also a part of, obviously, SAM. Your deployed app resources are deployed in a single unit called a stack. Parameters enable you to input custom values to your template each time you create or update a stack, and enable your users to define deployment configuration. So if you have a look at the previous one, it allowed you to define your S3 bucket for an output. So it's a very simple way of allowing your applications to be put into someone else's AWS account, but without having to hard code a lot of information. One of the big things and a big tip here is consider security of things like API keys and similar. So if we've got the AWS Key Management Service, which can allow encryption and decryption of information. Make use of that for information such as API keys for third-party services. So there is an application called the Splunk IoT processor, which allows you to respond to events from IoT and send to the Splunk HTTP event collector. And this uses parameters. And the way that it uses parameters is that there is a user-defined parameter within there, which is called the Splunk HTTP event collector URL. And that is the URL address of your Splunk HTTP event collector endpoint. So the assumption is that you would install this in your account, and you would already have a Splunk HTTP event collector endpoint. And when you're installing the application, when you're deploying it, you would have the parameter would be brought up, and you would basically put the URL in at that point. And the way that it then gets into the application is that the IoT function serverless function uses an environment variable which refers to the URL. Which is the little bit at the bottom. So that's how we use parameters within the context of SAM. And also something which is related and similar, each application, as we know, deploys as a CloudFormation stack. The output section declares output values that you can import into other stacks. So it's not just that you can provide parameters as input, but you can actually output information. And then that information can be used in AWS CloudFormation or even SAM, and it allows you to do cross-stack referencing. So it means that instead of having to hard code information into another CloudFormation stack or another SAM template, you can actually use information from those other from your original template and put it into that stack. So it's something you can do here. So you can, here we've got an output, which is the same Splunk IoT processor as before. And that function is very simple. It's using the IoT function ARN. The IoT function is defined below, but that's outputting that information so that if we wanted to, in another stack, use that output, we could use the Splunk IoT processor function output from this stack, and then we would be able to use that instead of having to hard code the information. So one of the other elements, which is a little bit more broad, is thinking about your input and output for your application. So don't think about your applications as very standalone. Think about it more as a boundary element, and then what's coming in, where is it coming in, and where is information coming in, and where is information going out, and how do I want users and customers to be able to use that. So an example from the application repository is the AWS Serverless Twitter event source. And this is quite a useful one, simply because the input isn't obvious. So the source of information you would think is going to be the Twitter search API. Well, actually, the input is the polling schedule from Amazon CloudWatch events. That is a configurable parameter, the number of minutes that you want to schedule on. That then triggers the Twitter search poll, a Lambda function. That then goes to the Twitter search API, which comes back. It then does a check on the Amazon DynamoDB database, which then checks to see whether it's seen any of the Twitter search API results before. And if it's seen any of them, it drops them. And all of the results it hasn't seen, it then asynchronously invokes a Lambda function, which is output as specified as a parameter. And that's how the application then works. So the input of that application is actually an Amazon CloudWatch event, and the output is a Lambda function. And now we come to having a look at private apps. These are really useful. So when you upload them to a region, they don't go across multiple regions, they just go into one. They're not visible to the public, they're only visible to your AWS account, but they can be shared across other users and other accounts. And this is really useful for sharing your internal resources and your internal patterns across your organization. And it's something that is something we would encourage because it allows you to create more reusable elements for your team and reusable elements for your organization as well. So let's have a look at building and deploying serverless applications. So one of the first things we would say before you start building anything is, does your application already exist? And not only that, does your application, does something similar to your application exist that you could copy? So the first place you start is go and have a look at the Serverless Application Repository and do a search. This is the Serverless Application Repository. There is a search bar in there. Type in what you're looking for and see if you can find an application that either does something similar or something the same. And that's the first place to start. It's very simple. Bear in mind that the core application consists of a SAM template and the associated code and template files. And you can see great examples that cover the monitoring, the media processing, machine learning, and more within the Serverless Application Repository. And if you're not sure if it's quite what you're after, bear in mind you can always go and have a look at the source code with all of the publicly available applications. You can go and have a look at their GitHub repository. You can even download and put it into your own AWS account very simply and take the code and change it. So one of the first things we're going to say about building new applications, yes, we would like you to do testing. We would like you to look at your own CI/CD pipelines. And this is going to start with doing things like unit testing, so NPM test and things like that. Depending on whatever your flow in your application is, this is the kind of tools you're going to be using. And we're also wanting you to look at local testing. So we have the SAM local tool. SAM local tool allows you to test locally your applications, your serverless applications using SAM local start API, for example. And you can also check events on your Lambda functions. And you can also deploy to personal CloudFormation stacks, and you can test using SAM package and SAM deploy. So these tools are available to you to be able to build locally and be able to test locally and deploy. What are the things that you need to publish applications into the repository? You need your SAM template, your AWS CloudFormation package, which you get through doing SAM package. You need your source code URL, e.g. your GitHub page. You need a README that describes your application. It's really useful to put in a more than a few lines in your README, because this is where applications, this is where people find out about your application and the kinds of parameters that they're going to need to put in. So the more information you can put in, the better. You'll also need to think about the license that you want it to be under and the license.txt file. And you'll also need to put in an Amazon S3 bucket. You also need to have an Amazon S3 bucket containing your build artifacts, and that will have to grant service read permissions to the Serverless Application Repository. You can find out how to do that within the Amazon documentation. So this is where you would go to publish an application, which is in the console/serverless repo. And this is what the page looks like. This is what it's like when you've got no applications published. And there's a big orange button that you click and it says publish an application. And in there you've got application name. You need to choose a short, memorable name. And then you need to choose your author name. So I would probably choose, maybe I was writing an application that connected to a third-party service, maybe something like Giphy. And then maybe I wanted to create one that had a random GIF generator. And then I had to choose my author name. So maybe I would call it Paul D. Johnston, like my Twitter username, maybe. And then the homepage of the repository, so that would be my GitHub repository URL, and then the description. So that would be the explanation of all of the parameters and what the tool actually did and the application. And that would explain it to people so that they could understand what they were getting when they hit the deploy button. And then the labels, this is allowing you to put in a few words to allow the search to be, people to find it through search, but also to explain to people what kind of other elements they might be getting. So you might, with that idea of a random GIF, you might put GIF and Giphy. You might put something similar like images or fun. Then you would also choose the license. You would input the license into the license, and you would put the README into the README section. And then this is the element where you would put in the actual version and the information around the code and SAM template. So you would enter the semantic version. So if you were uploading the first version, you might enter 1.0.0 or 0.1.0, whatever you decided. The source code URL, so that might be the repository release URL. And then you would upload the SAM template. So you would upload and browse and upload the SAM template. And when you've done all of those things, you would hit the publish application button, and you would see something like this, which gives you the application details. So it would give you the name, it would give you the ARN, give you the author, and it would give you the description. And it would also give you the versions on the right-hand side. It would also give you a delete application if you decided you didn't like it. And currently, this is a private application. This is because the visibility switch is set to off. When it's set to off, an application is private. This will mean that it's also region specific. So if it's uploaded to a region, it will not be visible to anybody else. Only when you hit that button will it become public, and that's when it will be available to everybody else. Also, if you wanted to update the version of the application, you would have to click add a new version, and then you would add in the new version of the information. So again, the semantic version, the source code URL, and a new SAM template, and hit publish version. And if you were creating a private application and you were sharing it with your team, you would find it within the Lambda functions create function parts of the AWS console, and you would click the Serverless Application Repository element, and you would search within there. So if I was sharing this with my team and I'd uploaded it to EU West 1, and I was in EU West 1, I would be able to search in there, type in random Giphy, and then it would find it in there. So let's talk about combining serverless applications. It's going on from just simply creating single applications and thinking about how we can make applications more composable. In reality, no application sits in isolation. Organizations may have many serverless applications in production. It sometimes feels like they're often separate from each other, but often they have inputs and outputs that are very much connected to each other. There are many benefits to combining applications. You can create a third application by combining two different applications into a third one. So, for example, an application that reads tweets with a specific phrase from the Twitter search API may then post to a Lambda function in another application. So let's have a look at this defined proposed application. So this is the AWS Serverless Twitter event source from earlier in the webinar. And this is a proposed application. So this proposed application is to analyze the tweet and publish to an SNS topic. So the input is just invoking the Lambda function, and the output is the ability to subscribe to the SNS topic. Very simple, two elements, two resources, but you can see that what we've got is the ability to put two applications together. I don't need to worry about how to read from the Twitter search API. I don't need to worry about rereading multiple things from the Twitter. I don't need to worry about any of those elements about the Twitter search API. I just need to create the one small part of the application, of the whole application. And I've created a full third application, which can then be allowing me to do something with the Twitter search. So maybe I want to have a look at sentiment analysis about the word serverless, and then I can send it to people via email. That would be a particularly simple example. It's a complete application. That's what large parts of development are done for you. And those applications are combined by the users, by the developers, by your team, without having to do lots of development or having to read API documentation. You've shared the resources to be able to do the work without having to worry about deployment. And the key here is you can actually combine public and private applications. So the AWS Twitter search API event stream may be public, but the second application may actually be a private application and then may be shared around the team. So you don't need to have all public applications to be combining together to make something interesting. And there are other benefits. You can have additional Lambda functions to route between applications. And it allows you to create even more combinations, to put things together, break things apart, to do more transformations in the data, so that if an application isn't quite what you were hoping for or doesn't produce the output that you were looking for, you can then transform that data easily through a single Lambda function or something similar, and it makes it more easily composable and it makes it more easily broken down. So if we have a look at how we might combine these two applications in a slightly different way, the two applications might be joined, instead of joined directly together, we might join them with a Lambda function right in the middle. That Lambda function might transform the information from the Twitter event source application and turn it into something slightly different for the analyze tweet Lambda function. It might also transform that data for a third application or a fourth application. It might push it into another format altogether. We might do something different, like sentiment analysis somewhere else, or we might choose to put it into some kind of logging format. There are a number of elements we could do with it, but this allows a lot of flexibility and gives us even more options for how we can join our functions together and our applications together. So, what have we learned? Well, we've had a look at what the AWS Serverless Application Repository is. We've looked at how you can find applications and deploy applications into your own AWS account. We've also looked at some best practices around considering your inputs and outputs, working with SAM, and also understanding how you might go about thinking about your users and how they might use the applications that you're building. We've also looked at how to build and deploy serverless applications and the kinds of elements that you need to think about. And now we've had a look at how you can build more complex applications by combining applications together. And that means composable elements, small elements, and then joining them with either directly joining or using Lambda in the middle. So go and have a look at the AWS Serverless Application Repository. Search, find things, use things, deploy them, get those applications out there, build more applications, and let's see what you can do. Thank you very much.